Hey guys, welcome to Unit 1. I'm excited because this is where we finally get to start solving equations. So just make sure you have your guided notes in front of you and you're filling them out. And we're going to start with 1.0a. And we're going to be combining some like terms. So make sure your notes look like this. I'm going to use purple today. And let's just define some terms first. So the first thing we're going to need to know is a variable. So this is something that can change, and it's usually represented with a letter. So that would be like X or Y or Z or N, any letter that shows that we're changing by a certain value. The next term we need to know is the coefficient. So that's going to be the number beside the letter. So that means X is being multiplied by 7. So the coefficient of X would be 7 for that example. So we've got variable is the letter or the quantity that is changing. Coefficient is the number beside that we're multiplying the variable by. And then the last term we need to know is the constant. So the constant is a fixed value. It doesn't have a variable, it's just the number by itself. So 2, it doesn't change, so it's constant. And then we have something that we are going to be combining to start off with, and that's a like term. So a like term means that it has the same variable and same exponent. Okay, so the coefficient doesn't matter here, the constant doesn't matter here. If we have the same variable with the same exponent, they are going to be like terms. So here, our term that we want like terms to is 12x squared. So we are looking for any terms with an x squared in it. So go ahead and circle on your guided notes any terms that are like x squared. So you should have had negative 15x squared and x squared. Notice that 8y squared is not right because that's not an x, okay? So that variable is different. 13x squared y, that's different. We've got a y in there. So those are not the same variables. All right, the next one we want to circle are constant values. So go ahead and see if you can pick out any of the numbers that look like are constant. So that would be negative 9 and 70. So all of the other examples have variables in them, so they are not constant. All right, so let's take a look at combining like terms. So I like to use shapes and colors and underlines and highlights or anything you can to keep these apart. So the first thing you want to do to simplify an expression is combine the like terms. So we have to identify the like terms. So I'm going to go through and I'm going to find all of the terms with the same variables and the same exponents, and I'm going to circle them. So I've got a 7x, I've got a negative 5x, I've got a 4x. So those are all, they all have an x beside them. So I can combine those. I can say positive 7 minus 5x plus 4. So I'm going to take those and combine them. So if I do 7x minus 5x, that gives me 2x. And if I take that 2x plus 4x, I get 6x. Okay, and then I'm going to go in and I'm going to highlight my other terms. So I've got a constant, another constant, and another constant. So I can again combine those. So that's just like adding. So that's like saying 3 plus 8 minus 1. So if I do that, I get 3 plus 8 is 11, minus 1 is 10. So my constant term is going to be positive 10. And that is a simplified version of that expression. We can do the same thing over here with exponents. So sometimes you'll have multiple different terms. So let's start with I always like to start with the biggest power, so the biggest exponent. So I'm going to say my 4x squared, find my other x squared terms there. There's 2 of those, so I'm going to combine them. So I've got 4x squared minus 7x squared. It's going to give me a negative 3x squared. And we're going to go ahead and scribble those out because we've already combined them. So we put them in our final equation. So now I need to find my other terms that are my other like terms. So I've got 4x and 2x. If I combine those, it's going to give me a positive 6x. Okay, and then again, my constants, let's use a different color there. I've got 5 and 6 and negative 3. So if we do 5 plus 6, that's 11, minus 3 is 8, a positive 8. So that right there is our answer. I know you're used to having one number as an answer, but when it says simplify the expression, we just need to get it to, we need to combine all the like terms. We can't combine x squared and x because they are not like terms. So let's do a couple more examples. So I'm going to do a couple with you, and then I'm going to leave you to do some examples on your own. So let's start with number 1. We've got our p terms that we're going to need to combine because they have the same variable and the same exponent. So I've got 7p minus 9p gives me a negative 2p. Okay, and then I've also got my constants. I've got negative 1 and 5. So if I want to combine my constants, I do negative 1 plus 5, which gives us positive 4. And that's our answer. Okay, let's look at an example with some exponents. Let's see here. Let's look at number 5. We'll do that one. So I've got my x squared. I need to combine those. So I've got 5x squared plus 7x squared. Okay, so that's going to give us 12x squared. And then we've got our constant left over. We don't have anything to combine it with, so it's just going to be plus 3. Okay, but what about, let's look at number 3. We'll do number 3. What happens when we have different letters? So if you look at this 5x and this 7y, they have the same power, right? They're not squared or cubed or anything, but they don't have the same letter, so we cannot combine those. So I want to go in and I want to find all my x's. So I've got my 5x, my negative x, remember that's just an imaginary 1 right there, and my 3x. So I'm going to combine those terms. So 5 minus 1 plus 3 is going to be 7x. And then I want to find my other terms, which are my y terms, and combine those. So it's going to be 7y plus 2y, which is a positive 9y. And that's my answer there. So go ahead and try the rest of these examples on your guided notes and see how you do with that. We're going to look at one more thing, and this is geometry applications. So this says state the perimeter of each figure. So if you remember, perimeter is just where you add up all the sides. So we're going to take all of these side measures and we're going to add them together. So we're going to do 2x plus 1 is that first side, plus our x, so second side, plus 3x, so our third side. And then we have a pretty long expression there that we need to simplify, and by simplify I just mean combine like terms. So I'm going to find all of my x terms, and I'm going to combine them. So I've got 2x plus 1x plus 3x, which is going to give us 6x. And remember, we've got a constant in there, which is 1, so it's going to be 6x plus 1. Okay, and do the same thing for the rest of these. So I'm going to add up all the sides. I've got 17 minus a plus 4ab plus 5a minus 1. And then again, you're going to go in and find your like terms. So we've got a negative a and a 5a. It's going to give us 4a. Okay, we've got a 4ab. You can have two variables in one term. And we're just going to throw that in there like it is because there's no other a-b term. And then we also have our constants. Notice that our constants are usually going at the end of the expression. That's just a good way to stay organized. So we've got 17 minus 1 is going to be positive 16. And that's as simplified as we can get. So that is our answer. Two more. It's going to be important on this rectangle here, so notice that they only give us two sides. But perimeter, we want all the sides added together, so you're going to have to fill in some information. So we know that this side is 3y minus 5, so our other side is going to be 3y minus 5, and the same over here. And again, you're just going to add those together. I like to write it all out and then simplify, but you can also look within your diagram. So I can say, oh, I have a 3y, a 3y, a y, and a y. So let's combine those like terms. So I've got 3y, 6y, 7y, 8y. So you can count your y's. You can also do the same thing with constants. So you can say, oh, I've got a 2, a -5, a -5, and a positive 2. So if we combine those, we've got those are going to give us -10, plus 2 brings us to -8, plus 2 brings us to -6. So that's an easy way to save some time there. I'm going to do the same thing for this one, so if you just want to find your like terms from the problem, that's fine. So we've got our k squareds. We've got 1 of those, 2 of those, 3 of those. So 3 in those sides plus a 2k squared down there, so that's going to bring us to 5k squared. Okay, and then we need our k terms. I'm going to highlight those. So we've got 1k, -9k, and k. So let's see, if we've got -9k plus 1k, that gives us -8k, plus 1k is -7k. It's our k term. And then we want our constants, which is 23 and -17. So we're just going to say 23 minus 17, which gives us a +6. All right, good job, guys.